we can read a lot about this right now. Can anyone tell us, as x approaches 0 from the left, what is the limit?
Negative infinity.
And 0 from the right, what is the limit?
Positive infinity.
Perfect. So what will you say that the limit as x approaches 0 from either side of f of x will be?
Less than equals 0.
Of course, awesome. Good. So every time a rational function has a value that makes it undefined, we are looking at potential vertical asymptotes. So I will say, in this case, x equals 0 is a vertical asymptote. Okay, let me write this because I hear all sorts of names. So asymptote. Okay, I'm gonna share my screen again, and let's take a look at some limits. And I like to look at limits between 20, where are they? 20, these limits. 29 through 40. Let's start with 30 this time. And we have the limit. As x approaches 5 from the left, x plus 1 over x minus 5. If you want, do we want to take a moment and stretch for a minute?
Just my back was hurting. I need to change positions.
We can stop for 1 minute, take a sip of water, and be right back. Is that okay?
Sure.
Okay, so let's just stop for 1 second. I'll get some more water. Perfect. So what we need to remember, every time we are determining a limit, that's the first step. Finding a limit. Step 1, plug it in. What? What am I plugging in? This number in the function. So what do I get when I plug in 5 in the numerator?
6.
Good. What do I get when I plug in 5 in the denominator?
0.
Perfect. So I want us to understand this very important fact. A number divided by 0, the limit, Limit has no hope to exist. Ever. No hope. 0 over 0, however, limit has hope. I'm not saying the limit exists. I'm saying it has hope to exist. I'm not guaranteeing, but I do guarantee that if it's a number, not 0, if it's any number except 0, a number over 0, there is absolutely no hope. So a number divided by 0 has 3 options, either infinity or negative infinity or DNE. This is doomed forever. It's either infinity, negative infinity, or DNE. So coming back here, knowing that it's this situation with no hope, I need to choose. Either I choose this, or I choose this, or I choose this. One of these 3. How do I choose? 5 from the left. So if this is 5, a number from the left, the closest that I can think of to 5 will be 4.9 to me. You can say 4.99, fine. But a close number to 5, but from the left. Now, don't plug it in the numerator, there is no need. Plug this number in the denominator and just tell me the sign. Don't calculate anything. You can, but I only need the sign. If you want to say the sign of 0, and you can say, but 0 doesn't have a sign. I agree, but I just need to know the sign here. What sign will you say?
Negative?
Yes. And now please choose. Knowing that the top is 6, knowing that the bottom is negative, which one will you choose?
Negative infinity?
Negative infinity indeed. Which means that x equals 5 is a vertical asymptote for x plus 1 over x minus 5. Any questions? Any questions on this function or this limit? This is the analysis. The first thing I need to do is plug it in. And now we can ask the question, wait a minute, how 0 over 0 can change into a number? You say that the limit has hope. How is it possible? So here's the answer, in case you're asking that. 0 over 0 is not called undefined. I think I'm on page 9. This is indeterminate. This can change into 5, 3, or negative 10. We don't know. It's indeterminate. And there is a total of 7 cases. And this is one of them. We're going to analyze the other 6 as we progress through the semester, so the course. So this is one indeterminate case, 0 over 0. You can expect anything. It's indeterminate. This is carved in stone, one of these 3. But this can be anything. We don't know what it is. Okay, so we have a few more minutes. Let's choose other limits.
How would you graph an indeterminate number?
You don't graph an indeterminate number. We are talking about the limit. That initially is an indeterminate case.
That was asked. Yeah.
Yeah. Good. So let's choose something else. Something with natural log, with sine, with secant, something else. So we can analyze.
Do the x cotangent x.
Yes, this one. Awesome. 36. Perfect. So limit as x approaches 0. I'm copying something else. Pi. So x approaches pi from the left. Sorry about that. Secant which one am I copying? Okay, no, I'm sorry. Did you say 35 or 36?
36.
Okay,
Yeah,
perfect. Okay, so this is x cotangent x. Perfect. Good. So x approaches pi from the left. Awesome. Good. Now, first thing we have to do is we have to remember what cotangent is. Can anyone tell us? Cotangent x is this over this. Yes, of course, it's 1 over tangent, but I want the simplest functions, trig functions.
Cosine over sine.
Very good. Cosine over sine x. Awesome. So I have x in front and I have cosine over sine. I'm going to analyze that. It's the same thing. X approaches pi from, say it again. Chris, you wanted to say something?
Sorry, you lost signal for a moment. I don't know if that's me or
I saw it too.
Okay, is it better now? Can you hear me?
We can hear you, but it's kind of frozen for me.
Should I do anything?
it's back now.
Yeah, it's back.
Okay, sorry about that. Good. So what is the first thing? I'm given a limit of a function when x approaches pi from the left with numbers smaller than 180 degrees or pi. So what do I have to do first? First thing, ever, forever, always.
Plug in pi.
Thank you. Awesome. So first let's plug in here. When x approaches pi from the left, x approaches pi. There is nothing here. Okay, now let's analyze this piece. As x approaches pi from the left, so let's talk about the unit circle. This is pi. Pi from the left means this in the second quadrant. This is pi. Pi from the right will be with angles bigger than pi. It will be in the third quadrant. But pi from the left is with angles smaller before we get to pi. Smaller than pi. So in the second quadrant. So can anyone tell us what is cosine at pi? What does it equal to?
-1.
Excellent. So this is -1 and this is pi. No problem. So the numerator goes to -pi because I have to plug it in. But now let's see what happens to the denominator. Sine of pi. You said 0, right? Okay, so then I know there is no hope. But I can't write this. This is for us to remember. I have to write infinity, negative infinity, or dne. Only one of these three. So now I have to analyze the sign here. In the second quadrant, this is carved in stone. That's -pi. There is nothing I can do about it. I'm talking about the sign of so-called sine of 0. So sine in the second quadrant. What is the sign? Sine of sine in the second quadrant.
Positive.
Good. So this is positive. So now the answer would be, this circle means jump over everything and continue here.
Positive infinity.
So the numerator is -pi. The denominator we established that is a positive number. So then the limit is,
dne.
one more time. Let's go back.
Negative.
Let's go back. We had positive over negative, and you said negative infinity. Why would you say negative over positive dne? Right? So we agree it's negative infinity. Now, I would have agreed with you if we had limit as x approaches pi from either side of this. From either side, from this side will be negative, from this side will be positive, and this will be dne. I would have agreed with that. But from one side, if the denominator is 0, we expect either positive or negative infinity. It could still could be in the DNE. It could be an oscillated limit, but in this case, it is negative infinity.